Hey Rifters and developers. I've been busy with the Unreal Engine 4 learning all the ins and outs, and I needed to add Razer Hydra control to my project, so I decided to make a plugin. And I'm going to share that plugin, so this is just a video showing the overview of how to use that plugin very quickly. If we're going to create a new project for this just to start with a fresh slate, and let's just call this Hydra test. Wait for the Unreal Engine to do its thing. And this is the basic third-person template that comes with the Unreal Engine 4. If we hit play, you can see with the mouse you can look around, and you can use your keys to walk all over the place. Alright, let's turn off real time for now. And if we go into Window Plugins, you'll see there's a bunch of engine provided plugins, and you can also provide your own plugins within the project, and they will show up in installed. And right now we don't have anything because this is a fresh project, so let's fix that. Let's go and open Unreal Projects, and we call this project Unreal. It's typically found in your Documents folder, Documents Unreal Projects, and then in there we find our project, which is Hydra Test, and that's the root folder. So we're gonna go and get the downloaded plugin, and it comes in with this folder and a README, and you just drag the plugins folder directly into the root. And once that's done, you swap over to the engine again and reopen the project Hydra Test. Wait for it to do its thing. And now that it's reopened, if we go into plugins and installed, you'll see we have a new category, and we also have the plugin detected. So all you have to do is hit enabled, and it will ask you to restart again. This is a typical thing with the Unreal Engine. And here it's enabled. Now to double check that in fact this is working, you can go into the window class viewer, and in here, if we just type in Hydra, you will see that we already have an actor class that's available called Hydra Plugin Actor. Now we could easily just create a blueprint from this, and it will show up in our blueprints right here, and this is the blueprint. And all you have to do is now right click to call functions or add events. In this case we can just add an event for whenever we, well, let's say we undock. Let's just say that we want to print a string when we undock. So we connect the execution. We say Hydra undocked, and let's resize this so we can see both of the things at the same time. We don't need this for now, and this is okay. Now, if you run this, nothing will happen because this is an actor, and the actor just has to be dragged into the scene to work. So now if we hit play again, now if I undock a Hydra, you will see that the event is emitted, and it shows up in the blueprint. Now this is good, but what if you want to actually do something interesting with this? Well, we could for example, take the controllers now, Hydra controller moved, and let's draw a debug sphere, and also let's take Hydra trigger changed, and let's add a conversion of float multiplication to scale this up a bit. We're going to use the triggers to change the radius of the sphere, and we're just going to use the position to put it in the center, and we're going to execute it every time the Hydra controller moves, which is practically every tick whenever the controller is not docked. Now this is really cool because it's taking this value, which happens from one event, and it's using it and storing the last known value when nothing's happening. This means that the blueprint actually supports some form of closures, which is quite powerful. Anyway, let's have a look. So in this case, when we undock, you can see that now it's emitting some events. And there we have our spheres when I pull my triggers to full. If I just let it go, they'll shrink. And it will change if either of them changes. So in this case, I just release it. They're smaller. And this is a one-to-one, the regular Hydra controllers that you think of. Okay, that's not particularly useful because we're still stuck with an actor. This is just an example actor. So we're going to go ahead and scrap this. We don't need it. So let's just remove the blueprint. Let's save this just in case. And let's make a way of controlling this character. So if we just go into plugins, I take that back. Let's go into the class viewer again. Type in Hydra. This time, get rid of the placeable filter. And we're going to create a blueprint off of the player controller. Let's just call it my Hydra player controller. Oh, in this case it was a crash, so let's reopen. This happens sometimes. Let's go into the class viewer again and do Hydra placeable, create blueprint, my Hydra player controller. And again, this will show up in your my Hydra player controller, and you have the same graph. Let me just close this for a second. I wanna. Okay. Let's open this up again. So in this case, you still have the same events. If we type in, joystick moved, and just print it. Actually, we need to add a build vector 2D. X and Y from the joystick. Spit out a string. And before, just like the last time, we need to do one small step more in order for it to actually be registered. In this particular case, in the blueprint, you can change your game to use your controller class right there. Now we can compile it, save it, close it, and let's resize this again so we can see what's going on. And if we hit play, and I move the joystick, you can see me spitting out the numbers from the joystick. And another crash. I'm gonna have to find out later what's going on. Okay, it seems like we retained most of this. Blueprint, the game, yeah, we're set. So now if we play, the joystick still shows up, and it's either joystick right now because we didn't specify any difference or limitation. Alright, so let's open up this and let's make this do something useful. If we do, let's get the pawn. So we get the player pawn, and we just go add movement. In this case, get rid of the context sensitive and add movement input. We target the pawn, and we do this after the string is printed. And we have X and a Y here, and a Z. We don't need a Z, so let's make a vector. This is what we're going to connect up, and we need to convert it. So let's do a break vector 2D. Here's the in vector, and we're actually going to cross these because, well, you'll see. So now just compile, And let's put this to the side. And let's hit play again. So we still have the same camera, but now if we move, it moves, but it's a little, it seems a little hatchy. Oh, but if we're moving in a circle, it moves pretty well. Okay, so what's going on? Well, the reason why is because this event only emits whenever there's a difference in the joystick from what it used to be. So we actually need to not connect this to that particular event, but actually do this every tick. And if we do this and we compile and play, you will now see that it will remember the tick, and you're now controlling the third-person character with your Hydra joystick. That's that simple with Blueprint extensions. That's pretty much it for Blueprint. You can take a look at what's included in the functions, but pretty much anything you can think of is being emitted. And apart from that, if you just want to do your own manipulations during every tick, so for example from this tick, instead of adding input here, you might want to do some pre-processing. You would probably want to get then all of the data, so you could grab the latest data. Hydra get. In this case we have twice as many. They're context sensitive, and then we get the latest data, and you can see this is all of the Hydra data in Blueprint format. And you can then do whatever logic you want in here, and then finally add the input to the pawn. That's it for Blueprint. Let's see how this. How we can extend this in C++ if you want to get down. If you don't like C++, stop watching right now. Otherwise, let's add some code to the project. Let's do. In this case, I want to add a custom pawn that will inherit these delegate methods. So I'll just call it a Hydra pawn. And let's open up the Visual Studio. Now automatically it includes your Hydra sources on the right hand side, so you can look through how this was implemented. So this is, for example, the Hydra delegate. It gives you the entire data structure, all of the events, and manual functions, things like that. And these are two data structures that hold the latest and the historical data. Now, so we need to we need to inherit the delegate. So let's do that. Let's go open up the source of the project and find the Hydra pawn that we just added. So in this case, we want to subclass it. So we'd add public Hydra delegate, and we include the Hydra delegate.h. If you look at the implementations, we do need to override something. These two particular functions, begin, play, and tick, is where we're gonna set our delegate and make the whole plugin tick. So we're gonna go back into Hydra pawn, add the overrides, line it up. Let's go into the actor. We're just going to copy the same code that we have here. I'll explain in a bit what's needed and why. So after renaming, we have two things. So this gets called whenever the game begins, and we're going to grab our actual module, the Hydra plugin, and we're going to check if it's available, and then get it, and then if so, then we're going to set the delegate. With the delegate set, we can just call the plugin and just call tick. The plugin will take care of absolutely everything else. You just have to subscribe to the events, and now you are set as the delegate. You will receive all the information which is defined again in the Hydra delegate. There's one more thing that we have to do. We have to actually go into the build and add the module, so Hydra Plugin, and unfortunately we have to add one more class. So we're going to go into the plugins and we're going to open up this is our project again, and this time we're going to go into source. We're going to go into the actual source, and here are our source files, and we have to drag in one source file from the private implementation or it won't compile. That's the Hydra delegate. Now that it's pulled over, we can go back into the Visual Studio, and oh, it's not going to compile. We need to change this is correct. The one thing we didn't add was the actual delegate to our file. So now that we have added it, drag it over and change this thing to just Hydra test, which is the name of this project. Let's wait for the compile. Meantime, let's take a look. So right now we've just overwritten the begin, play, and tick to make the plugin actually work and continue working. And when the compile will finish at some point, first compile is always really lengthy. After that, it gets down to a couple of seconds. The reason we have to copy the delegate is that because these are two separate build targets. So we forgot one more thing. We have the delegate, but we didn't add the actual. We have to add one more thing, which is include Hydra plugin. And with that, it should recognize everything. You can't open. This error means that you still have the editor open, so you just need to close that. Hot reload only works for small changes, not anything that includes a plugin will need to close the editor. Now that it's compiled, we know that this is compiled. The only thing we need to do is add an event that we want to subscribe to. So in this case, let's take let's go over here and just override something. Let's override button 1, B1 pressed. And let's add that to our overrides. Let's go into the implementation. And let's just print this out to show you that. And let's print out B1 pressed. You could easily key this in, but I'm just going to keep it simple. And let's do a final compilation and let's see this work. Okay, so now let's launch. Now we're still using the other, the player controller, so let's change that quickly to get rid of the player controller. And instead of that, we're going to change the spectator pawn to interesting. let's go into our project settings and then go into map and make game modes. Now we have our my game. Just make a new game mode and call it my game mode. And instead of the default pawn, we're just going to use the Hydra pawn. And that's it. Now if we play, we're below the world. But if we press 1, it shows up. And that's it for C++ implementation. You can add this to any class you want. And if you just follow the same steps, you'll be able to extend that class to respond to the Hydra in the same way. And if you add the methods that are added here, these blueprint implementable, you'll be able to also emit the blueprint events that you want. That's it. Hope the plugin comes of use to you. Enjoy.